So hello everyone, welcome back, and today we are going to study Kadan's algorithm. So this algorithm is basically used to find the maximum subarray. So you might be wondering, what is maximum subarray? So a maximum subarray is basically a small part of array, or a part of array which will give us the maximum sum. So let's say we have this array, so we need to find a part of this array which will give us the maximum sum. Let's say minus 2 and 1, so the output is minus 1, so hence it is not giving us a positive result even, right? Or if we would take 2 and 1, it would give us 3, and we already have 4 here. So like this, we need to find a part of array which is going to give us the maximum sum. Okay, so let's go through some of the key points here. The goal is to find the maximum subarray. We already discussed about this. Means to find the subarray with the maximum sum. How we are going to make this happen? Go through the array and keep adding all them. So here it started sharing the Kadan's algorithm. So first of all, how we can find this? Let's study some brute force approach regarding this. So what we can do is, we can make all the possible pairs of all the subarrays, or we can find all the subarrays, and then we can calculate sum of each and every element subarrays, and then we can compare each of them and find the maximum subarray. So in that situation, it is going to take like three loops, like one for finding all the subarrays, and then one for other, and one for other. So so when we are going to do like this, it is going to take order of n cube time complexity, but we cannot afford this, right? Because in case of problem solving, we need to find the most optimized way. So this problem can be solved using Kadan's algorithm. So what this Kadan's algorithm says is that negative number, if there is a number that is negative, then it is never ever going to support us to increase the sum. Okay, so we can simply discard them, or we can just simply skip them. So how we are going to do that is, like, using, here we can see how we are going to work on Kadan's algorithm. Go through the array and keep adding the numbers. So we are going to go through the complete array, and we are going to keep adding the numbers in a variable called current sum. So here we are talking about current sum variable. Okay, and reset if the current sum becomes negative. If the current sum becomes negative, start from fresh from the next number and set the current sum to 0. So if the number is found negative, means if if the current sum is found negative, in that situation restarted. Why restarted? Because we know that negative value is never ever going to give us a positive sum add. Means it is not going to add on in our value, right? It is always going to decrease the value. Let's say we have three values, -3, +3, and +2. So what is going to happen here is -3 is always going to decrease the value, so the sum is going to be 2 remaining. So that is why we are skipping the -3. So if we would have skipped the -3, then we would have left with 3 and 2. So in that situation, we would be in benefit on skipping the negative value simply. So next, what we are going to do after putting the value as 0 of the current sum, we are going to track. Always remember that the highest sum found so far. So here we are talking about max sum variable. So we always need to keep a track of the maximum sum. Why? Because and at any point the sum can be maximum, right? So we need to keep track of it. Simple. So we are going to come back to this time complexity and note later on. So let's view some code here. So as I shared, we need a variable called current sum and a variable called maximum sum. So the current sum is basically initialized as 0, and the maximum variable is initialized as int min. Why int min? Now you might be thinking, int min basically means minus infinity. Why do we need minus infinity? Because whenever we need to find a maximum value, whenever we need to find the biggest value, we are assigning it with the smallest possible value. So even if the value is negative, or like any minus 100, minus 10, it is going to be greater than the minus infinity, right? So it is always going to give us the maximum possible value. So that is why we are initializing it with int min. So this is provided us by the C++, and it is a type of a macro. Okay, that is why it is always written is in this same format in capitalized letters. Okay, so you need to keep care of this. Okay, take care of this. So here we have a simple loop which starts from I equals to 0 to size of nums array, and then simple iterator I plus plus. And what it is going to do is, it is going to add the current sum with the nums of I, means value of array in the current sum. What is the present value? Means the value at the current point, and in that we are going to add the nums of array, as we have already discussed here how it is going to set the current sum value. And then we have the maximum sum. So what it is going to do is, we need to find the maximum sum, right? So we are going to compare the max sum and the current sum, means the maximum sum since the starting of the array, and the current sum means we might be at any point of the array at so let's say we are at this point. So if the maximum sum would be here, then we need to take care from that point, right? So that would be our maximum sum, and current sum would be sum till overall. Okay, so that is how we are going to do. So what the biggest advantage of Kadan's algorithm is, it says if the current sum is smaller than 0, simply, which means if the current sum is negative current sum, in that situation what we are going to do is, in that situation we are simply going to reinitialize the current sum as 0. So what we have done here is uh, uh, simply, if the value is negative, means the current sum is found negative, then reinitialize with 0. So that what I said earlier, reset the value. So we are saying this part as the resetting part. Okay, so let's see by an example. So this example I have took from our problem question from the lead code, which is this problem number 553, which says maximum subarray. Given an integer array nums, find the subarray with the largest sum and return its sum. So we need to return the sum of with the largest sum from the subarray. Okay, so we have taken this example, and it says the output is 6. So we need to find how the output is 6 coming. 6 is coming here. Explanation is here. The subarray is 4, -1, 2 and 1. So this subarray is giving us 6 output. How it is giving us and how we find out, let's check it out. So here let's say, let me zoom out. So the max sum variable is here, which says minus infinity, and the current sum variable is here, which says 0. So when we are at I equals to 0, then the current sum is current sum plus nums of I. So current sum is 0 plus nums of I. Nums of I means first index, means nums of 0, which is -2. So 0 plus -2 is -2, right? So what is the maximum sum? So maximum sum is equals to max of max sum and current sum. So what max sum here is minus infinity and current sum is minus 2. Now compare both. Which is greater, max sum or the current sum? Current sum is basically greater than the minus infinity, right? So we will uh, put the value of current sum in max sum. Max sum is going to be as minus 2. I'm so sorry, minus 2. Yeah. And if current sum is smaller than 0, if the value is negative or not, current sum is negative, right? So then set it to 0. So okay, simply we did it like this. Okay, let's move to the next. So here we have 1. So minus 2, I'm so sorry, we have to take care of this current sum every time. So 0 and 1 means current sum is 0 and nums of I is 1. So let me move to the next. Okay, so 1 and 0 is going to be 1. Okay, now compare max sum and current sum. Comparing both, which is greater, current sum is greater, then again change the value of the max sum. Here we have 1 here. Okay, is the current sum smaller than the 0? Is it smaller? No, then skip this condition. Okay, again let's move to the next element. Here we have minus 3. Minus 3 and 1. Minus 3 is smaller, right? But I mean to say minus 3 and 1 is there. Then minus 3 plus 1 is going to be minus 2 again. Then current sum is minus 2. Max sum, now comparing both, max sum is already greater, so we do not need to change the value here. So now check, current sum is smaller than 0. Is current sum smaller than 0? Yes, minus 2 is smaller than 0. Then again set it to 0. Okay, let's move to the next. 4. 4 plus current sum means nums of I plus current sum. So it is going to be 4 plus 0 equals to 4. Comparing current sum with the max sum, it is again going to compare. 4 is greater, so put the value of 4 in the max sum. Now again check if it is smaller than 0. No, right? Let's move to the next. Minus 1. So 4 minus 1 is 3, and comparing both, max sum is already 4, already greater. That means we do not need to change anything in this part, right? Okay, so let's move to the next. 2. So comparing 3, adding 3 in 2. 3 plus 2 is 5. And comparing current sum with the max sum, is current sum greater than max sum, right? Then we can just simply choose the maximum of both. So maximum is this, then simply put 5 in the maximum value. Okay, then check if it is smaller than 0. No, then move to the next. Plus 1. So 5 plus 1 is 6. Comparing current sum with the max sum, current sum is greater, change the value to 6 and check if it is greater than 0. It is smaller than 0. It is smaller than 0. No, right? Then skip this condition. Iterator moves it to the next index, and here we have minus 5. So 6 minus 5 is going to be 1. Okay, so check if current sum and max sum, compare them. Max sum is already greater, then we do not need to change the value. If it is smaller, no, then let's move to the next. 4. 1 plus 4 is 5, and current sum is still smaller than the max sum, then max sum remains like this. So we have traversed the complete array in a single loop, and we have found our this. So what we are going to have it as our answer is this variable here. The maximum is going to hold the maximum sum of the subarray. So that is why we are returning the maximum here. So let's check the time complexity. As we can see, the for loop is going from 0 to size of nums, right? So the time complexity is, we can say simply, it is order of n, right? And we did not use any auxiliary space here, right? So that is why the space complexity here is order of 1. Simple. So what we need to take care is, let me put it in bold. We need to remember that negative number cannot ever support in increasing the sum. Means any possible situation, the negative number is not ever going to support us in order to find the maximum sum. So we can always cancel it out. Okay, so here we have found the complete solution. Now if you need, you can take a screenshot, and here we have the same question, and we can check, and let's submit this. I've already pasted the code here. Yes, here is our question. Let's analyze the time complexity. The time complexity is order of n. Okay, this is the submitted code. So what we can remember here is, just giving you a brief recap, negative number cannot ever support in the increasing sum. If you think about Kadan's algorithm, just remember this thing, that we need to eliminate the negative numbers. So you might be wondering where we can use it in real life, right? This is the basic question everybody have. So this is your work to find out that where we are going to use it. So let me give you a example here. Let's say you have a finance tracking app, and this is the total value you have generated each and every day. So, and we need to find the days on which we had the maximum profit. So let's say on the day 1 we had -2, means, and on next day we got a profit of 1, and next day we got a loss of -3, then 4, then -1. So in this case, if the we have got the profit and loss, then we can find the days on which we were having the best profit. Means we need to find some few days on which we had the best profit. So for us in this case, the situation was here, like 4, -1, 2 and 1. So that's how you can find an answer. So that's all from my side. Thank you everyone. I hope you enjoyed it, or might be you can post some of your comments below and suggest me something else, like what I can improve in this. And that's all. Thank you. Have a good day. Bye bye.